Good afternoon, everyone. In this video, I'm going to discuss about advantages and benefits of additive manufacturing processes. So, today's automated, tool-less, pattern-less additive manufacturing systems can directly produce the functional parts in the small production quantities. So, parts produced in this way, that means by using the additive manufacturing process, usually have an accuracy and the surface finish inferior to those made by the machining processes. However, some advanced systems are able to produce the near tooling quality parts that are close to or are in the final shape. More importantly, the time taken to manufacture any part once the design data are available is short and can be a matter of hours. So once the design be ready, the process of building the product or the prototypes is very short, and it can be a matter of hours. So additive manufacturing has ability to produce the physical models of any complexity in relatively short time. In the last 40 years, products realized to the marketplace have become increasingly complex in shape and the form. For instance, compare the aesthetically beautiful car body of today with that of 1970s. Then another direct benefits are on a relative complexity scale of 1 to 3. It can be noted that from a base of 1 in 1970s, this relative complexity index has increased to about 2 in 1980, approached 3 in 1990s, and exceeded the 3 after the 2000s. So these are the direct benefits. Relative complexity scale, based on the relative complexity scale, it scaled from 1 to 3 from the 1970s to 2000. However, the relative product completion time have not correspondingly increased. It increased from an initial base of about 4 weeks project's completion time in 1970 to 16 weeks in 1980. However, with the use of computer-aided design or computer-aided manufacturing and computer numerical control, that is CNC technologies, project completion time was reduced to 8 weeks. So eventually, additive manufacturing systems allowed the project manager to further cut the completion time to less than 2 weeks in 2015. So let us consider the evolution of the manufacturing processes. From the 1917 to 1980, the conventional model making and making a prototype. From 1980 to 1990, two-dimensional, three-dimensional computer-aided design, numerical control methods, and three-dimensional computer numerical control method and laser. So this slide shows the relative prototype and part complexity. So from 1990 to 2015, there are various methods of additive manufacturing process evolved. That means stereolithographic process, selective laser sintering, fused deposition modeling, laminated object manufacturing, and LENS, and so on. So these are various types of additive manufacturing process. This y-axis is indicates the processing time from 4 weeks, 8 weeks, 12 weeks, and 16 weeks based on the process. Then benefits to the product designers. The product designers can increase the part complexity. More organic, sculptured, and complex shapes for functional or aesthetic features can be accommodated. They can optimize the part design to meet the customer requirements. Then product designers can reduce the parts count by combining the features into single piece part. So to convert into the single piece part, we can reduce the part count by combining the features. So with fewer parts, the time spent on tolerance analysis, selecting the fasteners, detailing the screw holes, and assembly drawings is greatly reduced. So the product designers can minimize the use of materials and optimize the strength weight ratios without regards to the machining cost. Finally, they can minimize the time consuming discussions and evaluation of manufacturing possibilities. These are the benefits of the product designers. Then benefits to manufacturing engineers. The manufacturer can reduce the labor content of manufacturing since part specific setting up and programming are eliminated. Machining or casting the labor is reduced, and inspection and assembly are consequently minimized as well as. So reducing the material waste, waste disposal cost, material transportation cost, and inventory cost for raw stock and finished parts can contribute to the lower overheads. Fewer inventors are scrapped because of fewer design changes, and the risk of disappointing sales are reduced. Then in addition, the manufacturer can simplify the purchasing since there is only one form of raw materials, a spool of wire or vat of liquid and so on. The production manager can purchase one general purpose machine rather than many specialized machines, and therefore reduce the capital equipment and maintenance expenses cost, and also minimize the need for specialized operators and training. So these are the benefits and advantages of additive manufacturing process to the manufacturing engineers, to the product engineers. So in the next video series, we will discuss the different types of additive manufacturing process. Thank you for watching.